So reaction time again. Reaction time, as previously, is normally distributed with mean 1.25, standard deviation 0.46. And we want to know how long reaction time has to be among the slowest 10% of reaction times. A tricky part of this question is remembering that a slow reaction time gives us a big value of x. So what we're looking for here is the 90th percentile, the value which has 0.9 as the probability getting less than it, or 0.1 as the probability getting bigger than it. So we want to find x such that the probability of getting bigger than x is 0.1, or in other words, the probability of getting less than or equal to x is 0.9. How are we going to do that? Well, first of all, let's find the z-score that would have 90% of values less than it. We'll do that using the norm-in function. The answer ends up being 1.28. And remember, z is equal to x minus mu over sigma. So we've just worked out that for the standard normal, the chance of getting less than or equal to 1.28 is 0.9. So, because x minus mu on sigma is equal to z, the chance of x minus mu on sigma being less than or equal to 1.28 is 0.9. We're just gonna find x. Okay, so x minus 1.25 over 0.46. So equal to 1.28. X so equal to 1.25 plus 1.28 times 0.46, which is something. $1.84 approximately. So if he's longer than if he's at 1.84 seconds, then that's in the, if he's longer than 1.84 seconds, he's in the slowest 10% of reaction times. Now, there's another way to do this actually. We didn't have to standardize. It's good to know how to standardize because we will need that in life. But there is actually some extra arguments on norm min for norm CDF. So for this first question, all right, we did this first question this way. We got 0.568. What we could have done was we could have gone norm CDF of 1, 1.25, 0.46 and subtracted that from one norm CDF of 1.75, 1.25, 0.46. That gives us the same answer. And down here, instead of doing things this way, we could have gone, what's norm inv of 0.9? So what's the 90th percentile of the normal distribution with mean 1.25 and standard deviation 0.46? And we would have got 1.84 again.